So this exercise is related to Newton's law. I have solved like first 20 pages as the question numbers are not in sequence. That's why the page numbers are important. I have solved about first 20 pages. So I'll start with 21 onward, and you will go check the recording of the first 20 pages. I'll share after the session. Here, page 21, when some birds take off from the ground, there is no lift initially. These birds push off from the ground with their legs. This is the same scenario as we discussed, like how a person can jump. So same thing, the birds for a takeoff, they push, initially they don't have the lift. So they push the ground. As a result, the ground will apply an upward force, and that upward force will be more than the weight. So it will create an acceleration, upward acceleration. So the bird can lift off from the ground. The following graph shows the downward force exerted by the leg on the ground during a takeoff. So you can see first, so when the bird is on the ground, so example, this is representing the weight of the bird. This part, what happened, the bird did not push the ground. So what it shows at this point, the weight of the bird is equals to normal contact force or the downward, because the following graph shows a downward force. So in this case, the bird does not push. So the normal contact force and R are equal to each other. So we can say like this is 0.61 or 0.60 Newton, which is a downward force equal to normal contact force 0.60 Newton upward or 0.6 Newton upward. Now, this part, why there is a decrease? Because as the bird tend to push the ground, the position of the center of the gravity is changing. That's why this moment the downward force start to decrease. But then what happened? Then the downward force suddenly increases. What is the reason for this? Initially, this part, why there is a decrease in the downward force? Like it is less than the weight. The main reason for decrease in the downward force, as the bird tend to push the ground to get the lift, the position of the center of the gravity is changing. That's why the downward force is varying. But when it is pushing the ground, the downward force is increasing, like it will be more than the weight. Weight is already 0.6 Newton or 0.61 Newton, you can also say. But now there is more downward. 0.6 Newton is already there. That is the weight of the bird. So weight of the bird is already 0.60 or 0.61 Newton. Now, as a result, what happened? It start to push the ground. So what is the total downward force? The total downward force is, each box is representing, here 10 boxes equals to 0.4. So each box is 0.04. So this will be 2.04. So that if the total downward force is equals to 2.04 newtons, and out of that, if 0.6 Newton is the weight, so how much force is applied by the bird? That will be the sum of the two. Like 0.6 is this. This is 2.04 is a total downward force. So if 2.04 is a total downward force, and now we consider it with reference to the earth. So earth was pulling the bird by a force of 0.6 Newton. That is the weight of the bird. So 0.6 Newton and 0.6 Newton. But when the bird pushes the ground, more downward force, so there will be more upward force from the ground. And how much is the upward force from the ground? The upward force from the ground will be 2.04 Newton. And this 2.04 Newton is not a pair force of the weight. So if 2.04 Newton is upward and 0.6 Newton is downward, so more upward force than the downward force. That's why this bird will get a lift or it will accelerate upward. And if we want to find its acceleration, how we can find the acceleration? The resultant force will be 2.04 minus 0.6 equals to ma. And this is a point, it's just loses a contact. This is a point, it loses a contact. That's why there is no force from the surface, no downward force. So the question is, with reference to Newton's law, explain how the downward force from the leg enable the bird to take off. So how this downward force allow this bird to get a lift or take off from this? So first thing, the idea is that when the bird is pushing the ground downward, there will be an upward force in opposite direction. Like there will be an upward force or equal force, but in opposite direction. And that force is more than the weight which create. So that force will be more than the weight, and that will create a resultant force. And because of this resultant force, the bird will accelerate upward. Is it clear, this part? So you will mention the bird will push the ground downward. According to Newton third law, the ground will also exert an upward force. And that upward force is more than the weight or the gravitational pull on the bird, which create a resultant force. And whenever there's a resultant force, according to Newton's second law, the object will accelerate. So the bird will accelerate upward. The next, use the graph to calculate the maximum acceleration of a bird. The mass of the bird is 0.063. So how you can calculate what is the maximum downward force applied by the bird? This one is a maximum downward force which is applied by the bird. So this is, we took 2.04, you can take 2.05 because it's not exact. So if you want to take the maximum, say you took this as 2.05. And we already know that the weight of the bird, this is the weight of the bird, which is about 0.06. Each box is actually 0.04, so I can take 0.062 or 0. Or I can take this as a force. So this one is 2.05 and the weight, say we took as 0.61 or 62 because it's not exactly at 0.60. So I took as 0.6. So what happened? The bird is pushing by a force of 2.05 Newton downward. So there will be a force of 2.05 Newton upward. According to Newton's third law, forces act in pair. Now with reference to Earth, the weight of the bird we can get by its mass into like 0.063 or 0.062. That is the weight of the bird. And the upward force on the bird is 2.05. So there will be an upward force of 2.05 Newton. As a result, 2.05 minus 0.62, this will create a resulting force on the bird. And that result, according to Newton's third law, resultant force is equals to ma. So 2.05 is upward, 0.62 is downward. As a result, there will be an acceleration upward. And that acceleration is equals to ma, or force is equals to ma. The mass of the bird was given 0.063, and we can work out its acceleration. So it will be 2.05 minus 0.62 divided by 0.063. That will be the acceleration of the bird. Or the maximum acceleration of the bird.